Welcome and hello to the TUI in Live today. My name is Rebecca Garrick and today we will talk about contrails. And you have the chance to ask questions later, but maybe to get you in the mood, I want to tell you the story of how I met contrails, because before I started working at TUI, when I saw these white lines in the sky, I thought about freedom and traveling, and it was very positive. And then I met two men and they ruined that for me. And then there was a short moment of despair and then they gave me hope again. And these two men are here with me today. And I will introduce them in a second, but my role here today is the one of the moderator. I will guide you through the talk on contrails, and I am happy to have Christoph Todt here. He is the head of environmental sustainability at TUI Airline.
Hello from my side. I'm Christoph Todt. I joined TUI more than 24 years ago now. And in my current role, we try to lower the environmental footprint of our operational activities. And I can't do that on my own. I have a great team and we have many, many engaged, wonderful colleagues in TUI who help us that.
And one of that is Tony. He is usually working above the cloud, but for this call, he lowered down to his computer in his home office. He is a co-pilot or first officer with us.
Thank you, Rebecca, and welcome everyone. My name is Tony Schweigert. I'm a first officer with TUI Fly. I've been with TUI for about 8 years now, and I met Christoph about 2 years ago, and he introduced me to the very, very interesting topic on contrails. And just like Rebecca, it changed my mind, and their negative effects has been really tremendous on me. So we've been working really hard to avoid these, and it's been a joyride.
And spoiler alert, this call will not end on despair, but on hope. But let me introduce the third person. We also have Stefan Simon here. He is the community manager.
Hi, everyone, and welcome to our LinkedIn Live. Today is your chance to ask live questions in this show. So just use the comment function below this post, and then we will answer this directly in this show. And we would also like to know from where are you dialed in? So we are always curious. We know we are streaming here all over the world, but we are curious, where's your location? Where are you based at the moment? So let us know in the comment function and see you later.
And what I would also like to know is how hot is it outside of your office? But let's also jump into the topic. We will talk about contrails. And when we talk about contrails, it's always about sustainability in aviation. And we usually only talk about CO2, or a lot of people only talk about CO2. So Christoph, maybe you can tell us what are contrails and what are the differences between CO2, contrails, and the effects of that?
Yeah, both of them are greenhouse gas emissions, and they are the most relevant ones which are emitted by aviation. CO2, you mentioned, everyone has heard about it. Contrails probably have seen, but probably don't know all the differences. And I would like to compare them a little bit. If you start with CO2 and the criteria of visibility, you will never see a CO2 picture in a picture gallery about aviation climate impact because it's invisible. But for sure, if you Google it, you will see an aircraft with a contrail. And I'm relatively sure that you will look differently at the sky after this call, because you might have realized that sometimes airlines create a contrail, sometimes they don't. Sometimes they disappear within a few seconds, and sometimes they stay for hours and become bigger and bigger. And this is actually about occurrence and longevity. Only 5 to 10% of our flight difference is actually where we emit contrails, while with every kilogram of fuel we burn with an aircraft, and this is the given technology, and this is before we have enough sustainable aviation fuel, creates a defined amount of CO2, and that is 3.16 kilograms with every kilogram of fuel we burn. It just happens, and it's for sure. Now, the other very interesting difference, which not many people know, is CO2 stays basically forever, for years, for centuries. That means if you would stop flying today, we would still see the impact of our flying from yesterday in the future. While contrails, and this is what you have actually observed when looking into the skies, they disappear. And from a climate impact, the ones who stay for more than 10 minutes are relevant, not the ones who actually vanish within a few seconds. Now, there's one big difference about certainty when it comes to the science. We are relatively sure about the climate impact from CO2, but we have quite a higher uncertainty when it comes to contrails, and that's for different reasons. First, it's so difficult because it depends on certain conditions, which Tony will talk about, to predict that a contrail is formed in the first place. It's even more difficult to predict whether a contrail stays for longer than 10 minutes or hours. And then the really difficult thing is to actually estimate the climate impact from that contrail. The last 2 points in my comparison were big surprises to me. First of all, CO2 is always bad to the climate, to the environment. There's nothing good about it. But if you form contrail at the right time of the day, which Tony will refer to, you can actually create a positive climate impact. And that is something I didn't believe in the first place. And what I didn't believe either before I heard about it is they have a comparable climate impact. Yes, the uncertainty for CO2 is smaller, but actually the uncertainty for contrails, which is bigger, covers the lower and the upper end of CO2. That means scientists are sure that it has a big and significant impact. It can be lower than CO2, but it can also be significantly higher than CO2.
Okay, so now that we covered the very basic, it's kind of like our airplane is up the cloud. So I want to hand over to Tony. How are contrails formed and what are they made of?
Yeah, thank you, Rebecca. Well, to have these contrails that we sometimes do see and sometimes we don't see, we need a couple of things to happen at the very same time. And some of them occur on every flight and some of them don't. And that's what makes them so special. First of all, what we need is an air packet to be very, very cold, usually around about minus 35 degrees. And it's something we always have, and it's very prevalent at higher altitudes. When we cruise the aircraft, we actually have temperatures at around minus 50, minus 55 degrees. So we have that on each and every flight. What we don't have on every flight, and it's actually the most important one, is what the relative humidity of that air packet is. It needs to be very, very humid, especially in relation to water. It needs to have more than 70% of water in terms of relative humidity. But, and now that's hard to understand maybe for everyone who is not into science too much, is that its relative humidity regarding to ice needs to be oversaturated. And there needs to be more than 100% of ice particles already. So it's super saturated. And it's something that doesn't always occur. It depends on the season. It depends on where in the world you are. And this is something that has been a challenging factor because it depends on weather forecast, and then models will come on top of that weather forecast to tell us where these areas are. Another thing we need is the water vapor, and that's something that I, as a pilot, have always believed, is that we see these white lines in the sky. And we knew these were just water vapor, and it is the water vapor coming from the combustion of kerosene. So every time fuel is burned, and that's something that we need to do as an airline pilot, we have water vapor, and in addition to all of that, we need tiny little soot particles to kind of start the process. So we have a soot particle. Those are these tiny particles that happen when we have combustion going on. So on these particles, the ice crystals will attach themselves and will pull in the other ice crystals that are super saturated in this area. And if all these come together, so it's very cold, it's very humid, we have a lot of water vapor from the engines, and we have these tiny soot particles, that's when contrails are formed. And then they can be short-lived, they can be long-lived, or even worse, they can spread into a real cloud layer. They're called contrail-induced cirrus clouds, and that's where the issue starts. Yeah. During our trials in the company, I was lucky to start the initiative as a pilot, and we see here one of our very first flights where we tried to make sure that the current models are accurate enough. What you're seeing here is our aircraft flying behind another aircraft on one of the airways across Europe. So we're following the other aircraft that's flying ahead of us about 10 miles. And we knew this area had a prediction for contrails. And you can see the aircraft in front of us did leave a very, very big contrail. It was big enough to cast a shadow on the lower cloud layer. You can see that here in the still picture. This was one of the first flights that gave us the confidence that the prediction models we use in our flight planning tools are very, very good, because it was spot on. We knew it was going to happen, and we could actually see it forming ahead of us, and our aircraft passing right behind these lines, making sure and understanding that these were the perfect conditions for these contrails to form. And as you can see, they're spreading out, they're very long lasting. And that's the issue we've been trying to tackle here.
And when I saw this video for the first time, I kind of wanted to cough because it feels like exhaust. And I thought that they were like stars in the sky. Then I thought it was exhaust, and I would be interested to hear from all of you. What did you think, or think until today contrails are, what they were? We'd be happy to know from you, or maybe you even knew about the impact of contrails. But it's not exhaust, but it's something a lot more difficult, what you just explained, Tony. Why is it that we don't want contrails or long-lasting contrails? What are our environmental concerns?
Yeah, we need to turn to physics a little more. It's even optical physics, and it was tough for me as well to get my head around this, as it's not just the water vapor clouds that seem so harmless. So what we understand now is that the sun emitting its energy in form of shortwave radiation, and once it hits planet Earth, it will turn to heat. And but once it hits the surface of the Earth, when it reaches the Earth as shortwave radiation, it can actually be reflected from cirrus clouds or contrails. But most of the warming effects of the sun will happen once it hits the Earth, and then during the afternoon and during the night, this heat will try to escape the planet towards back to the universe. As a long wave radiation. So it's outgoing long wave radiation. It's changed from short wave radiation and is now turned to long wave radiation. And contrail cirrus clouds are a lot different than regular clouds we see maybe when we have bad weather coming in, because those clouds are mostly made of water droplets. But contrail cirrus clouds are ice crystals, and they have different properties, and they have a different optical thickness or thinness. And what happens is that we have that greenhouse effect that most of us have heard of, is that the heat actually cannot escape the planet. It gets trapped, it gets absorbed, it gets spread out. And the net effect of this is it's very positive warming, unfortunately. And this effect is something that is new. Science has understood this effect, and the numbers are scary, to be honest.
And if you ever make small talk on a party about contrails and you want to avoid talking about long and short wave radiation, you can also say that they drastically increase the greenhouse effect, because the heat just gets trapped. So we don't want that, because we already are fighting global warming. So what can we do to avoid contrails, Tony?
Yeah, it seems easier than initially thought, is that we now have great tools in our flight planning department, our flight planning software, and teams that are responsible for our flight plans that calculate the most optimum routing from A to B to our summer destinations. Is once we have these prediction models kind of switch on and tell us, well, there is this area that's depicted here in this gray shaded cloud. It's called the predicted ISSR region. ice super saturated region. Something we can easily do is just step above it or climb under, descend underneath it. So we file a new flight plan. We make sure we have all the requirements to make that happen, and we just avoid this, what we call it, a vertical avoidance. So sometimes as a passenger, you might feel a change of pressure on your ear because the aircraft starts to ascend or descend mid-flight to avoid these regions. It can be either. If this extent of these contrary areas is very big, we've seen it might be necessary to actually reroute the flight in terms of lateral navigation. So what we do is we have a picture of these areas and we file a flight plan that might turn a little further off the original routing, its optimum course, and try to avoid these areas and where they're predicted.
So you say it's not that easy, but it's definitely doable. I know that because you've done it. You and your colleague have done it. Christoph, maybe you can share some of the results in the trials that we have made to avoid contrails.
Yeah, so we have done about 200. Well, actually, this was not this. This was a Tony slide because it pretty much shows how that works when you reroute an aircraft.
Yeah, if we can go back just one slide before that, because that's it's almost the same video. It's later on the stages of our flights is you can see the aircraft climbing, and just as we can see this cloud layer there, we stopped the climb because that's something we predicted to happen there, and we stayed underneath this cloud layer. This is the region in the air that had predicted these formation of contrail clouds. You can see these are contrails made from other aircraft. You can see on the ground that there's some patterns, some shaded patterns from shadows cast from other aircrafts, other contrails, and we just stayed just a tiny bit below that because there isn't much space up there, and there's a lot of other aircraft flying. But this worked quite nicely, and post-flight we could make sure that this actually prevented us from flying through these regions. And with the next slide, this is something that we as pilots can see is once we usually take off, we try to climb the aircraft to the optimum flight level for flight. The higher, the better. This is something that we always knew. And what's changing now is that we're making sure that when all the factors that come into having the most perfect flight plan, we also look at the contra areas and have a look at we can just overclimb it, like in this example. And this was a flight I was lucky enough to do. We were supposed to make a step climb to avoid the first contra area. This is, if you see the picture there at the bottom, we were taken off from the Canary Islands and we're flying to Frankfurt. And just as about we hit Portugal there, this is about where Lisbon is. This was where we needed to climb the aircraft to avoid an area. Unfortunately, and this is very interesting, is we weren't able to climb because there was another aircraft 2,000 feet above us, just where we wanted to be, that was following our routing. So we had to make sure we have enough space between this aircraft and us. And so unfortunately, we weren't able to follow that flight plan as it was filed. And we hit that tiny spot just a little bit. And the post-flight analysis did show that flying for a few minutes in that region did cause us to create warming contrails. As we were able to climb the aircraft, just a little later on, we were flying towards the northern part of Spain. This is where the Cantabria Mountains are that will lead to the Bay of Biscaya. And just as we were approaching that, there was another aircraft passing underneath where we had the prediction for the contrail zone underneath us. And we couldn't see any contrails in our flight level or our altitude, so to say. But we could see that the aircraft passing underneath us did create this very long and very long-lasting contrail. So we knew the models were correct. And once the prediction models and the forecast, the weather forecast, worked nicely together. This can be done with just climbing the aircraft a little higher than we would have done on a regular flight on that day.
So I can see, or I can think that if you are flying a plane and then you see that is an immediate success that you were able to avoid it. About successes, now maybe the question that I wanted to ask earlier, were there any successes or results that we've already achieved, Christoph?
Indeed, Rebecca, we have done about 200 flights by now in total, mitigation flights. And we started with individual flights, single flights, and we selected them on the day of operation. Sometimes we were lucky to have two aircrafts in the same region at the same time. That gave us an opportunity. And that region was actually predicted to have warming contrails. That gave us the opportunity to reroute one of the aircrafts and let the other fly as planned in order to compare the result. And we have seen differences. And I think from a scientific point of view, that is definitely a success. But given all this uncertainty, it's difficult to talk about success. We decided in February to do something different, which we haven't seen before. We selected individual flights. Now, what we wanted to do is, and we wanted to understand the operational limitations. Is it possible to reroute all the flights of 1 week of the German airline? And what do we see in terms of new learnings and challenges? So what we have done is actually we looked at 313 flights in that 1 week in February, and we ended up rerouting 84 of them. We could have done more, but for certain reasons, timing, slot, delay, we couldn't do so. And I would regard as a success to say 15,600 tons of CO2e. It's not CO2, it's a CO2 equivalent. And this is a unit which tries to compare the climate impact from different greenhouse gases, which are not easily to compare. If this would have been fuel, 15,600 CO2 equals 250 return flights from Frankfurt to Cyprus. So this is a huge amount of CO2e, which is basically the climate impact coming from those warming contrails, which could have been avoided, given that this is a modeled size. So it's not measured. You cannot measure it. You can model it. And this is where the uncertainty kicks in. The number is so big, not because it's always like this. It was a huge contrail. We call it outbreak, cluster, big hit. We had a huge area over the Portugal, Spain, and France area where almost every flight produced contrails for a very long part of the flight. Did this happen? Well, we don't know because we couldn't measure. But even with the uncertainty, let's assume it's only 10% of this 15,000 is correct, then it is still a factor of 20 better than the additional fuel we have burned in order to achieve this, because we only needed 18 tons of additional fuel to achieve this modeled climate impact. I would regard this as a good result from that 1 week trial.
I think that's a pretty good result and a lot of saved CO2. What's also good is that we already have a lot of comments and questions. Stefan.
Yeah, fantastic. Thank you for this great input. Actually, I think I can share this. I learned also a lot, so that's not part of my daily job. No, but Rebecca, you've asked also for some temperatures and so where the people are at the moment. So we have a very big range, let's say, but also some colleagues are dialed in here from the Hanover office. For example, greetings are going out to Inga Meyer with 33 degrees here. Yeah, no confidence in the sky right now, she's saying. And we have also, I just noted down here some locations, from Malmö, Sweden, Tenerife, Belgium, south of Italy, Vienna. So we are all over the world, and that's TUI, right? We love it. There's one question coming in, I think, from the person who has the farthest distance here. It's from San Francisco, actually. So the question is coming in from, where do we have it? From Joachim. Joachim from San Francisco. He said, it's very early in the morning. Thank you very much, TUI, for being so active and vocal about addressing your contrail warming. Many more airlines should be doing what you do. What do you think? Very few airlines are doing anything about their contrails. Now I can read it on here. It's a little bit longer. Do you have any advice for other airlines on how to get going with addressing this unwanted climate warning. So I think a question for you, Christoph, a little bit talking about what are we doing and what is with the others. I think so.
Yeah, I actually know Joachim, and it's indeed not an easy. Not an easy question, and he knows that. One of the unfortunate things,
always the good ones.
one of the difficult things are that yes, we can reroute, but we are not certain about the results, and that is a thing which we also thought in the very beginning. No, if you end up harming the environment, that's not good. That requires us to define certain selection criteria for the flights to be on the safe side. Because otherwise, you can be, as I said, you can be argued by the climate scientists who believe rather it has a low impact, that the additional fuel spent is not worth the rerouting. The other side is, yes, it costs money because it doesn't come for free. And it's not only the fuel, it's also the additional ETS credits you might need or COSIA credits you might need. And that's not an easy one to do in an airline. It requires you to actually convince many people in the airline to do this. You need to look at your processes, and Tony knows about that. Flying, any changes in flight are really, really critical looked at. Safety is for us number one. We cannot risk anything in that regard. And if we add another dimension to what a pilot should look at, this needs to be carefully done. So you cannot start tomorrow with doing flights. You need to review this, you need to analyze this, you need to work on that. And therefore, I think you need some people who really like the topic, who are willing to go the extra mile, and perhaps here and there some extra money in order to make that happen. It doesn't say that no airlines do it, and we have international projects. IAGOS is a super international project where 11 aircrafts around the world collect data every day with every flight, and humidity is one of this data. We have European projects like Siconia, where airlines participate in, and where we try to understand the operational requirements, but also want to understand and improve the science. And we have national projects like Project Decult in Germany, where 4 of our German airlines participated last year in order to improve the understanding of contrail avoidance.
Thank you very much. And at least we have now really proven that this is a live show, yeah, with real questions. Okay, Rodrigo is asking, is it true that contrails have an overall slightly higher impact on the environment than CO2? Are dispatcher or optimizer tools or software being used to calculate and minimize contrail emissions for a given flight? I think we had this a little bit already, but it's a very important point. So thank you for this question, Rodrigo. It's really worth to emphasize the answer for this. Who wants to? Both of our...
I can probably take the first one, Tony. And I tried to explain it with the bandwidth of certainty around climate impact. So this is the bandwidth and the magnitude of CO2. And the bandwidth of magnitude of contrails is like this, which means it covers the upper band of CO2 and goes even beyond, but it also covers the lower band of CO2 and goes below. That means the first question depends on which scientists you ask. One scientist might tell you it has less impact, significantly less than CO2. Another one might say, oh, it has at least 2 or 3 times as much as CO2. So we have to live today with this uncertainty. We cannot solve the question tomorrow. But this is why I said they are comparable in a way. They're in the same ballpark. And so there's no definite answer to the first one, unfortunately.
And maybe to tune in from my side, stepping out of the role of the moderator, but I feel like when it comes to sustainability, it's super important to listen to science. This is why TUI is working together with scientists to find out more. And with the look on the global warming of this planet, maybe we can't wait until everything is figured out into detail, but it's worth working with scientists to be able to have 100% certainty soon.
Yeah. 100% correct, Rebecca. And I think what is important is I was trying to explain this. A lot of things have to happen at the same time, so it's only very few flights that do create these, and where a lot of energy, a lot of heat is being trapped on this planet, and it is a lever we have right now. It's something we can do immediately as an airline. And we have the tools with this. So our dispatchers, this is the second part of the question, is they have this very modern and agile software that will help them identify these areas and optimize these flights. We call them contrail optimized flights, that will help us avoid these regions and make sure that the flight is from A to B planned accordingly with all the necessary requirements that any flight plan needs to have, and to make sure we are fully compliant and fully safe, of course.
Thank you both. Time is running. I think we have time for a last, let's say, quick question and maybe a quick answer. So Linnea from Finland is asking, as a passenger, would I notice any difference between a normal flight and one avoiding contrails? Yes or no? Who wants to?
I think I should take one. Well, to be honest, we make changes, like especially altitude changes. Those are very slight and minute changes. So maybe sometimes if you're very sensitive to pressure changes on your ear, you won't feel a difference. You might feel the engine spooling up a bit as we climb even more. Or maybe you have the impression that the most perfect flight you've ever had is already over because you feel like you're descending, but you're not. You're still flying in cruise. I'm just trying to avoid these, and we make very slight course adjustments. We're not making huge and abrupt turns. So safety is the number one issue for us. Comfort as well. So if you're a frequent flyer, you may notice something, but on the other hand, I suspect that as a passenger, it feels like any other flight.
Okay, that sounds like good news to me. There's a way to change something and you won't even notice when you're a passenger. Thank you for all of your questions. I think there would be tons of more questions. If you are watching this on a recording, don't hesitate to reach out if you have any questions that weren't answered. But maybe, Christoph, you can sum up just really briefly what we talked about, just so we all have it in our minds before we go to the lake.
Yeah, the key takeaways, at least for me, and hopefully for many of you, are contrails do have a significant impact on global warming, and it's caused by us, by humans. But only a few flights or even a less flight distance actually form the contrails which are relevant for climate impact, and those are the persistent, long-lasting contrails. And finally, there are options, and we can say so from at least from our flights, that if prediction works well and is accurate enough, we can actually avoid quite a big change of this climate impact with relatively low costs and in relatively close distance, near distance.
All right, wonderful. Thank you everyone for tuning in. I learned a lot, even though I'm working with the topic for a while now. If you're interested in the topic in general, you can look at our website, you can follow us on LinkedIn, and if you follow us on LinkedIn, you will also not miss another TUI live. And if you're about to head out to the lake, if you're about to prepare dinner and want to know more about travel and sustainability, I can really recommend this podcast here. You might recognize the person moderating it. It's a TUI podcast on sustainability of the future of travel called We're On It. Thank you and see you next time.